Okay, I want you to try something for me right now. Go look at your calendar.
Hmm.
It could be the one in your kitchen wall, maybe the one on your phone. What do you actually see?
Most people see a cage.
Right. It's a grid. It's just boxes.
Yeah.
Meeting at 2, dentist on Tuesday. It's a scheduler.
Purely functional. And a little stressful, honestly.
Exactly. But what if I told you that for some of the most advanced civilizations in history, that grid, it wasn't a scheduler at all.
It wasn't about appointments, it was a flight manual.
A flight manual, a high-precision instruction manual for flying a spaceship.
And just so we're all on the same page, the spaceship here is planet Earth.
So today we are diving into some fascinating research by Joana Burnay on ancestral astronomy. We're looking at the Maya and Aztec civilizations, but we're stripping away, the crystal skulls and the apocalypse movies. We're looking at the mechanics.
Right.
The big idea here is that their calendars, the Haab and the Tzolkin, were actually rigorous scientific instruments. They were mapping celestial mechanics.
It really requires a total shift in perspective, doesn't it? We usually categorize these cultures as, well, spiritual.
Rituals and temples.
Exactly. But Burnay's work argues that for them, spirituality was geometry. They were mapping the space-time of our planet with a precision that, well, it frankly embarrasses the calendar on your phone.
Okay, but that's a massive claim, though. I mean, we've got satellites, we've got NASA. You're telling me that people without telescopes understood orbital mechanics better than the average person today.
I know, it sounds huge.
I was pretty skeptical when I first opened this file.
It is a big claim, but when you start tearing apart the math, which we're going to do, it's really hard to argue with the numbers. They weren't just counting days, they were calculating trajectory.
So our mission for this deep dive is to decode these systems. We're going to figure out how they map the sun, the moon, and this is the part that blew my mind, our actual physical movement through the galaxy.
And to do that, we have to start with the concept of the year, the solar year.
The Haab.
Correct. The Haab. Now, on the surface, this looks familiar. It's a solar cycle, 365 days. You might look at that and say, okay, they knew how long a year was. Big deal.
We know that too. 365 days for the Earth to go around the sun.
Does it, though?
Well, roughly. Plus leap years.
And that's the first problem, isn't it? Our modern Gregorian calendar is a bit of a disaster, astronomically speaking. It's just a political patchwork. Why does July have 31 days and September 30?
I still have to do the knuckle trick to remember that.
Exactly. It's arbitrary. It was decided by Caesars and popes. There's no astronomical event that says, okay, the month ends now. It's just a way to chop up time so we can pay rent.
Right.
The Haab, on the other hand, is designed completely differently. It divides the 365 days into 18 months of exactly 20 days each.
Plus that weird little 5-day period at the end to round things out.
The way, yeah. But let's focus on the 20. Why 20?
I just assumed it was because they counted on their fingers and toes. A base 20 system.
And that's the standard anthropological answer. But Burnay points to something much more complex. It's about the geometry of the spiral of Earth's translation.
Okay, spiral of translation. You've got to break that down for me. I know the Earth orbits the sun. That's a circle or, an ellipse. Where does a spiral come from?
This is where you have to visualize the whole system in motion. We think of the solar system as this, static dinner plate with planets just marching around the rim. But the sun isn't stationary. The sun is hurtling through the galaxy at an incredible speed.
Okay, so the sun is moving, and we're basically chasing it.
Right. We're orbiting a moving target. So if you trace Earth's path through 3D space, we're not drawing a closed circle. We're drawing a corkscrew. A spiral. We are spiraling through the universe. That's the translation.
So we never actually come back to the same spot.
Never. Every single New Year's Day, you are millions of miles away from where you were last year. You're further along the spiral. Now, if you want to map a spiral mathematically, you need a harmonic division that fits that curve. The Gregorian months, 30, 31, 28, they're jagged. They don't fit the curve at all.
It's like trying to measure a curve with a straight ruler.
That's it, exactly. But the Haab's 20-day cycle,
It fits.
it's the harmonic unit. It's the precise slice of that spiral, like the teeth on a gear. If you divide that spiral movement into 20-day chunks, the geometry just resolves perfectly. It lets you track trajectory, not just duration.
That puts our calendar in a whole new light.
Yeah.
It feels so dead.
Yeah.
Like we're just making hash marks on a wall to mark time passing. Whereas the Haab is a navigation chart for where we're actually going.
That's a perfect way to put it. The Haab is living time because it aligns with the actual motion. But that's just the solar side. That's the highway we're on. Now we have to talk about the passenger.
The moon. And this brings us to the Tzolkin, right? The sacred calendar.
The Tzolkin is 260 days.
Which always confused me. 260 doesn't line up with the solar year. It doesn't seem to match the lunar cycle of, what, 29-ish days. It feels random.
It seems random if you only look at one object, but the Tzolkin isn't about one object. It's about the relationship. The lunar-Earth weave.
Okay.
The Tzolkin is built on two numbers, 13 and 20.
And there's that 20 again.
The 20 is the common denominator. It's the gear tooth that locks the solar calendar, the Haab, to the sacred calendar, the Tzolkin.
Yeah.
It means every so often the gears line up perfectly.
Oh, the 13.
But the number 13, that is the heartbeat of the moon. The text mentions a 12-13 proportion.
Yeah, I tried to wrap my head around that. Is it like a musical polyrhythm or something?
It is exactly like a polyrhythm. Think about the rotations. The Earth is spinning on its axis. The moon is orbiting the Earth. Those two movements create a ratio, a harmonic. For every 12 rotations of one cycle, you get 13 of the other. So 13 isn't just lucky or unlucky. It's the beat of the moon's orbit relative to our own spin.
So see if the Haab maps the big spiral around the sun. The Tzolkin is mapping the complex little dance the moon is doing around us while we're on that journey.
Precisely. And by meshing them together with that 20-day unit, they created a unified map of space-time. They could look at a single date and know exactly where the Earth was in its spiral and exactly where the moon was in its dance.
But wait, this is where I got a little stuck. You're talking about this perfect, clean mathematical grid, 20 days, 13 days, it fits together like Legos.
Right.
But when I look up at the sky, the moon is messy.
Messy how?
Well, it changes shape. Sometimes it's a sliver, sometimes it's full, sometimes it's gone. And the cycle isn't a clean 20 or 13. It's like 29 and a half days. It's sloppy. How do you square this perfect math with the messy reality of the phases?
You've stumbled onto the exact conflict that Burnay highlights. And here's the aha moment.
Okay.
The phases aren't the reality.
What do you mean? I see them. They're real.
You see them, yes. But the source refers to the visual moon versus the physical moon. In fact, it points out that in a lot of folklore, the moon is called a liar.
A liar, because it changes shape.
Because it deceives your eye. Think about what a phase really is. It's just lighting, a shadow play. It depends on the angle of the sun and where we are. It's a visual trick tied to rotation. If you only track the phases, the cycle of lunations, you get that messy 29.5-day cycle. It's a distortion.
Okay, so if the phases are just a trick of the light, what's the truth?
It tides.
The water.
The water doesn't care about light. It doesn't care if it's cloudy or if the angles are weird. The water responds to gravity. The cycle of tides tracks the mass of the moon, not its image. And if you track the tides, you find the true orbit, the translation of the moon, which is a clean 28-day cycle.
That is wild. So the whole growing and shrinking thing is a distraction. To know where the moon actually is, physically, you have to look at the ocean.
Right. The visual is the illusion. The physical pull is the reality. The Tzolkin, with its 13 and 20 structures, is rooted in that physical reality. It's a gravitational calendar, not just a visual one.
It's like the difference between looking at a photo of a dumbbell and actually lifting it. The photo might look light or heavy, depending on the shadows, but your muscles know exactly how much it weighs.
That's a great analogy. The tides are the muscles of the Earth feeling the weight of the moon.
So we have the solar spiral, the Haab, and the lunar gravity, Tzolkin. But there's a third dimension here. I mean, literally a third dimension. The text talks about the nodes.
Yes.
The nodal cycle.
I'll be honest, whenever I hear lunar nodes in astrology, my eyes kind of glaze over. It sounds like mystical jargon.
And it often is, but Burnay makes it sound like hard mechanics.
Yeah.
It is hard mechanics. Think of it this way. Imagine a massive highway that's Earth's orbit around the sun. We're driving flat on the pavement.
Okay.
Now imagine the moon is a motorcycle circling us, but it doesn't stay on the pavement. It goes up a ramp, crosses over the highway, goes down into a tunnel, and comes back up.
So it's weaving up and down relative to us. Exactly. It has a vertical axis. It's moving in 3D space. The nodes are just the specific points where the motorcycle hits the pavement, where it crosses our orbital plane. There's an ascending node going up and a descending node going down.
So if you aren't tracking the nodes, you're only tracking the moon in 2D. You're missing the depth.
Correct. And that depth is crucial.
Yeah.
Because that's the mechanism of eclipses.
Right. Because then eclipse doesn't happen every month.
If the moon stayed flat on the highway with us, we'd have an eclipse every single month.
Yeah.
But because it's bobbing up and down, it usually just misses the shadow. So an eclipse is a precise alignment of 3 cycles: the visual lineup, the vertical lineup, and the sun itself.
It's like a combination lock. You need the tumbler at the right number, but you also need to push the key in to the right depth.
And when that lock clicks open in Eclipse, the ancients didn't just see it as lights out. This brings us to the biggest, most mind-bending part of the research.
The galactic connection. This is the part that I think really justifies that whole spaceship Earth idea. Because up until now, we've just been talking about our local neighborhood, sun, moon, Earth.
Right.
But Burnay argues they were looking way, way past that.
They were using eclipses as markers. Think about it. If you have a clock that is so precise, it tracks the sun, the moon's gravity, and its vertical position, and you track that clock over hundreds of years, you start to notice something else. You notice a drift.
A drift.
The background stars are moving, or rather, we're moving relative to them. The research suggests the study of eclipses allowed them to measure the Earth's undulating movement through the galaxy itself.
And this connects to Quetzalcoatl, the plumed serpent.
The feathered serpent.
Yeah, I always thought that was just a cool monster.
Yeah.
A dragon god.
That's how mythology remembers it. But look at the image. A serpent. How does a serpent move?
It slithers. It undulates like a wave.
Like a sine wave. Now, go back to our image of the Earth spiraling after the sun. If you were to look at that path from the side, what does it look like?
It looks like a wave.
It looks like a serpent. Burnay suggests that Quetzalcoatl isn't just a god. He's an archetype of the orbital path. The plumed serpent is the Earth's trajectory through the Milky Way.
Wait, so when they carved those snakes on the temples, they weren't just worshiping a snake, they were drawing a graph.
They were visualizing the mechanics of the cosmos. The feathers represent the flight, the movement through the air of space. The serpent body is the undulating path. It's a perfect piece of data visualization.
That is. That gives me actual goosebumps. It completely reframes the rituals. I always pictured them terrified of an eclipse, banging drums so the sun would come back.
That's the primitive view we impose on them. But this research implies that during an eclipse, they weren't scared. They were calibrating.
Calibrating.
An eclipse was a moment of synchronization with the galactic order. It was a moment all the gears, sun, moon, Earth, nodes locked into place, pointing directly toward the center of the galaxy. It was a direct line of communication with what the source calls the north of the universe.
They were checking their coordinates. So the temples, the pyramids, the calendars, it was all one big dashboard.
It was a dashboard for a civilization that saw itself as a crew on a vessel. They needed to know where they were in the great river of stars.
It just makes our modern view of time feel so small. We look at our watches to see if we're 5 minutes late for a Zoom call. We're obsessed with the micro time.
We're obsessed with the 24-hour cycle, which, by the way, they understood perfectly. 1,440 minutes of rotation, they had that down. But they didn't stop there.
We stopped there. We live in the day-to-day.
We treat time as a straight line. Monday, then Tuesday, then Wednesday. A relentless march. They saw time as a cycle, a wave, a spiral. They understood we're repeating patterns, but always at a new level of that spiral.
We're staring at the clock on the dashboard, panicking about the minutes, but we've completely covered up the windshield. We don't know where the car is going.
And that's the tragedy of losing this knowledge. We are very good at knowing when it is, but we've largely forgotten where we are.
The source leaves us with this really provocative thought I want to chew on. If these calendars, the Haab and the Tzolkin, are actually maps of our travel through the galaxy, if they really are flight manuals, then what are we?
Well, if you don't have the manual and you don't know the destination, you're just a passenger.
A passenger.
A passenger sits in the back, plays on their phone, and just waits to arrive. A pilot watches the instruments, understands the engine, and sees the horizon. The Maya and Aztecs, they were pilots.
And maybe that manual's still there. It's just carved in stone, waiting for us to learn how to read it again.
The stars haven't changed, only our attention span has.
So next time you glance at the calendar on your wall, or you look up at the moon, try to see past the grid. Try to see the spiral. And remember, you're moving a lot faster than you think. Thanks for taking this deep dive with us.
Always a pleasure.
See you next time.